This assessment asks us to identify the planes of symmetry in the molecule shown. So that I don't have to worry about the Weatherman effect, I've redrawn the molecule over here. The first symmetry plane that we're going to notice is one that cuts through here. Why is this a symmetry plane? This is a symmetry plane because the left side of the molecule is reflected on the right side of the molecule. Now you might look at this and say, wait a second, that doesn't make sense because here we have two double bonds between these carbons, and on the right side we have only one double bond. This is where that concept of resonance is important, because really this structure is made up of two contributing resonance structures. And so we can kind of think of these double bonds as being going throughout the two ring system. So if you've ever seen benzene represented this way, it really makes the symmetry plane more clear. So this is a plane of symmetry because of the resonating double bonds. For that same reason, we have another plane of symmetry that cuts through this methyl group, and a plane of symmetry, a third one, and the final one that cuts through this methyl group. In each case, what's on one side of the line or one side of the plane is reflected on the other side, assuming again that we account for the resonance.